As we go through tonight, if you got questions, jump in at any time, and Pete and Norm, if you've got someone who's got online questions, jump in and let me know.
Sure.
I don't mind being interrupted. I'm not on my laptop, so I'm not going to get too heavy into talking about processing. I'll talk in abstract terms because I don't have any way to demonstrate it. But I'm going to spend a lot of time just talking about what goes into getting a good technical shot of an aurora as well as a good artistic shot of our work. Because when we do imaging in space stuff, it's very, very, very technical, and that often can be very challenging on its own. But I think aurora is great because we have a lot of artistic decisions that we can make that's a little different than other forms of astrophotography, where we're trying to capture a more or less accurate scientific representation of what's floating up in space above us. I grew up not far from where Starfest is held in Chesley, Ontario. This is a shot from about, probably about 3-4 years ago from the back of my dad's property. And you can see the Milky Way and the glow that you see off to the left there. That's from the town of Hanover, which is about 25 kilometers away. When I grew up there, it was absolutely, utterly pristine dark skies. Probably was somewhere around the Bortle 2 to Bortle 3 range. I think it's probably Bortle 4, moving to Bortle 5 these days. But it's still a heck of a lot better than where we are here in Southern Ontario. And one of my early memories as a kid was going out to the north end of town to our friends who lived out there when we first heard there's going to be Northern Lights. And in my mind, Northern Lights were going to be spectacular, like that first shot. And of course, I went to look visually. I was about 10 years old. And if anyone want to guess what I saw?
Nothing.
Nothing. Well, there was definitely Northern Lights. But as a kid with really bad vision who hadn't been quite diagnosed to get glasses yet, it was a very disappointing experience. And it wouldn't be until years later, actually, as part of going down to Fingal with the RASC group. And I'm trying to remember who might have been, if anyone here would have been down there with us. We were all trying to image at Fingal. And those of us who were imaging was back in the days where pretty much everyone was on DSLRs. And we were complaining that the lights at Frome, which had just been put in, had gotten so bad, we were getting like a red-orange glow on our shots. And we were all kind of grumbling about bad light pollution. Dave McCarter turned around and went, holy, and then said a word I won't repeat in the room with young ears. And the entire northern sky was on fire, and you could actually visually see the reds and the greens. I was like, that's what I was looking for when I was 10 years old. And it was amazing. And Dave took a whole series, because he was the only person who bought like a regular camera lens. We all had telescopes. And he had a regular just DSLR and like a zoom lens, and he was taking rapid shots around to get it. And it was published in Star News. It was pretty good. That's what I looked like way back in the day, and my love for all this. Did anyone get Owl magazine in the 70s and 80s? Yeah. This is where my love of astronomy started. My uncle had gifted me a year-long subscription to Owl, and it came with like a free back issue. And what was really cool is the first time I went to do a public talk a few years ago, I went to the publishers of Owl and said, like, do you remember there was this thing and there was like a whole centerfold of the space shuttle, and they actually found the issue for me for the cover in their archives, which was pretty cool. But I don't know how many of us, I'm 50 of our generation, like Owl magazine was kind of how we got into space. Now, aurora, of course, are all happening because of our lovely sun doing all kinds of things. And we're in a very exciting time right now. Is the most active that the sun is in the current solar cycle. And in fact, it's far more active than it's been in about 20 years. So if you have access to a solar scope, one of the great things you can do when you live in the Great Lakes and we have nothing but clouds all night long is occasionally we get 2 to 3 minute intervals where there's blue skies around this glowing yellow ball that we all forgot about for about 3 months. Go grab a solar scope and take a look. And I do that almost daily if I can. And now that we've hit equinox, it's actually getting easier and easier because it was so low in the sky through the winter. Even those rare days we saw it, sometimes you couldn't get a good one. So this is taken through, I've got an older 60 millimeter double stacked blunt. You can do some really amazing things on it. As you can see, this is from, I believe, in the fall, and the sun, has just been stupid active. And of course, the more that's going on in the sun, the more those magnetic field lines slap. We get what's called coronal mass ejections that hit our way, and that is eventually what triggers the northern lights. So we have our cycle of sunspot progression, this all time with northern lights. And as you can see here, we are right at the peak now. The peak is almost double what it was in the last solar cycle. So there was, if you look at the chart here from left to right, it did look for the last, 40, 50 years that we were on a decline. I think you could argue right now that that's starting to reverse. It'll be very interesting to see. We should be now probably within the next, I think, 4 to 5 months hitting the peak. There's always a little bit of fluctuation, but it's pretty consistent. So it will be interesting to see where ultimately we peak at. And the last few days, whenever I've looked at the sun, there's still a ton of stuff going on. If you don't do this in the next couple of years, it's going to be a very slow 10, 11-year cycle for you till this starts to come back again. So take advantage of it now while you can. What's interesting is how regular this has been for the last 300 years or so. And this is all the solar cycles going back to the year 1600. Of course, in the last 100 years, we've had a lot more consistent data, but people have been tracking sunspots for a very long time. We have the Maunder minimum back in the 1650s to 1700s, where there just really wasn't a whole lot going on that was observed. And it was around 1750 that we started to have really good scientific records that we can still rely on. You can see that on top of the solar cycle variation within each solar cycle, there's some variations within the variations at a bigger scale. And if you look, it does seem to be into the last solar cycle that we crested a maximum in the 1950s, 1960s, come down, and I'm warning now if we're starting to see an uptick again if it follows that same sort of pattern that's there. So like anything that's unstable, there's oscillations, and I think what's neat in the sun is you can actually see there's oscillations on top of the oscillations, and it'll be very interesting to see what happens. This is one of the best graphics that I have ever seen in terms of explaining how why aurora are happening. Of course, the solar wind is constantly pushing towards us, and the Earth's magnetic field gets turned into a tadpole shape. And the stronger the winds come from the sun, particularly if there's coronal mass ejections, the more that's going to push up against us. But at any given time, some of that material from the sun is going to be pushing down to the north and the south pole. And aurora will come about, just see if I can go back here if that'll restart, I don't know if it will. Aurora will push this magnetic field tighter and tighter and tighter and longer and longer and longer. And so more of the energy, more of the plasma, more of the particles, which all have a magnetic field, can get in closer and closer to us. And the really strong auroras that we had in May and October of last year were so strong that the Earth's magnetic field pretty much rang like a bell for quite some time after. And I've got a couple interesting graphs where there's already been some scientific studies done on that, where you can literally see how it's going. So the more that hits, the more it goes. And the big things that come into play is how fast is that solar wind? How dense is that solar wind? And is the magnetic alignment of the solar wind the same or the opposite of the Earth's when it hits? And that's why it's very frustrating when you see in the news or you get the alerts on your apps about possible aurora and you go out and like half the time it's not very impressive. Well, it's 50-50 odds whether it's north to south or south to north. So you take your chances, but you want to hang out for a while, and I'll show you a couple of great time-lapse videos that tell you why it's so important to hang out for a while, because it may not be very exciting, but you don't know what's coming behind it that might have suddenly flipped direction. And of course, we're not the only planet to get aurora. This is one of my favorite shots from Hubble on Jupiter, and of course you can see in the northern hemisphere there quite a substantial aurora, and I think on most planets, most of the gas giants anyways, there's been visible aurora. There was, does anyone remember the hexagon that was happening on Saturn a few years ago? Was that aurora or was that a wind? Was that a wind? Yeah, that one was a wind. So yeah, it's kind of neat to realize we're not the only ones. Any planet that's got a magnetic field is potentially going to have aurora. Now, when we're trying to figure out whether or not we're going to be able to see it here, there's something called the KP index, which is used. It goes from 0 to 9, 9 being where we were in May and October of last year, 0 being nothing is happening. Generally, I find in and around the London area, KP5, you can probably see something distantly on the horizon. KP6, then you can definitely see something from where we are. The really exciting days are when we get up KP7, KP8, KP9. KP9 is strong enough that sometimes the aurora goes south of us, as it did in May and in October, which is pretty remarkable. When you think of, us sitting somewhere along the 42nd parallel here, that means the aurora is pushed down, more than halfway, right, around the world, which is kind of crazy when you stop to think about how much power goes into that. There are a ton of apps. I don't know if anyone else has a different opinion. I find most of them vaguely unhelpful. I have yet to find one where I can say to you, that's the app you want to get. I had one for a while and it was pretty good, and then the developer discontinued it. It was like a hobby of someone, and they updated the various software platforms for iOS and Android, and it was going to cost them money and they dropped it. But you can pretty much pick any of these. If you have an app on your phone, they'll send you alerts. You can usually set the KP threshold. So again, set it to 5, maybe 6, to make it worth their while in nighttime. But they're all good. I've got 2 or 3 of them because I find no single one of them seems to be terribly reliable. They're all pulling their data from different places. But what I do find really helpful, I don't know if anyone's noticed in the last, I don't know if it's the last few weeks or last few months, Astrospheric, which is a great astronomy app in general. If you pull it out and you scroll down now on the main screen, you'll see all the bars for how much cloud, what the atmospheric transparency is like, smoke, all that. But you go down, they now actually have an aurora section. And it's actually one of the best laid out aurora sections for any app that I've ever seen. So on the left here, you can see there's an image of the globe, and on your phone, you can sit there with your finger and move it around. And when there's a aurora oval, you'll be able to see a graphical representation of that to give you an idea of how far extended it is. On this day where I took the screenshot, unfortunately, there was nothing. It was like KP 0.125, something like that. So there really wasn't too much there. But what's also interesting is they have on there the graphs going back about 5 or 6 hours. We have a couple of satellites that NASA and ESA have set up into orbit as early warnings for aurora and CMEs, and you'll be able to see on the top how fast the solar wind is moving, density of the solar wind, and then the really important one here, which is BZ, which for us in the Northern Hemisphere, if you see this as a strong negative number, it usually means we're going to see a really spectacular aurora with lots of structure, which is what we're looking for. Any one of these on their own may or may not be sufficient to trigger a good solid aurora for us. If you see them all, if you see the top 2 pointing up really high and the bottom one pointing really low, it's going to be a spectacular night. But one of the interesting things is the combination of those 3 factors. And I'd argue that probably where you see the best aurora is when the magnetic field, which is the BZ measurement, is a negative number. So that's clashing against our part of the world at the pole. So that's where we get the strongest aurora. But I've seen this go quite low, but if there's not a lot of speed and not a lot of density and what's come off the sun, you really don't see much at all. So it's really a combination of those 3 factors. Another fantastic app that I've discovered in the last couple of months is Zoom.Earth. It's both a website and an app. If you haven't seen it, it gives the best satellite cloud cover and precipitation cover and wind charts. It just brings everything together, and it's absolutely fantastic. It's very easy to use. So the other thing, of course, is we can have strong aurora, and us being astronomers, our greatest enemy is clouds. And Craig and I, you'll see, well, you've seen one shot where I did the KP 5.6 spectacular aurora there. We actually had to be looking at all kinds of meteorology apps that Craig had to try to figure out where the heck to go that we wouldn't have clouds blocking our view to the north. I've never seen an app as simple and effective as this, and it's updated about every 15 to 20 minutes. It is a fantastic tool for aurora, but for astronomy in general, because as good as Astrospheric is, it's based on models of what might happen. This is based on what's actually happening. The models are pretty good, but there can be a lot of variation, local variation. The one thing that the models, Astrospheric, is not very good at is snow squalls generally. You'll be all excited because we have this beautiful clear night, and then there'll be a streamer and it'll be crap. And you go, why wasn't that on there? It's because that's a local phenomenon coming off the lake. So I find this is a super useful tool. The best tool, which is a website, not an app, is this website here, swpc.noaa.gov. Basically, it's the Space Weather Prediction Center. Now, unfortunately, our cousins to the south, as you may have heard on the news, are having some government staffing, funding, and many other problems going on, to put it delicately. And my understanding is a crap ton of people at NOAA have been laid off and let go, and there's a lot of concern about the viability of the organization. That'll be a massive loss to the space community. I am somewhat hopeful that someone will point out that modern technology and satellites are entirely dependent on the warnings that are being given by this organization. They're doing a lot of things that then allow the Starlinks, the Telsats, all the satellites to put themselves in safety mode if we're going to have a large event. So I am hoping that the industry may start lobbying to go, no, this is a really important government function. And we'll talk in a bit about a couple of solar storms in 1989 and 2003 in particular that were real wake-up calls to the importance of this kind of space forecasting. If you dig down into this website, you get a ton of information. One of the things that you'll see on the top left, there'll be a 24-hour observed maximum. So not only do they monitor aurora, but they're also monitoring radio frequencies, and I've forgotten what the other one is, but basically there's a number of different wavelengths that they're monitoring constantly for solar storms to see what's going on. We'll often have radio blackouts because radio waves are moving at the speed of light, whereas the solar wind, as fast as it is not at the speed of light. And so we can have a radio blackout and then maybe have a storm 2, 3, 4 days later, depending on the speed of what's coming off the sun. So you can actually, if you see like there's a strong radio storm going on, that'll tell you, hey, it's going to be a good couple of days for aurora. Question?
Is there something that would be able to measure the sound? Is there sound to it?
So
even though our ears may not.
Yeah,
I'm just curious.
It's interesting. There's been a real movement in the last few years that I have seen a number of space phenomena that they're not necessarily giant, so there's no sound in space because it's a vacuum.
Oh, yeah, that's right.
Interestingly, aurora can have sounds, rarely, and they need to be super strong. And I think what you're hearing in that case is just the electrical discharges within the atmosphere. But it is, there's a lot of scientific research now that's being done about converting light waves into acoustic waves so that we can dig through and find information that as humans, it's harder for us to get information from light. But if you convert it to acoustics, you may be able to hear patterns and things that then let the scientists go back. And it's, I heard it with, maybe someone else remembers, I think it might've been some of the sounds of Saturn and Jupiter and the gas giants, like converting some of that data. And I think there was the black hole merger a few years ago. Somebody had done a similar kind of thing. And I mean, some of it's just interesting, but I think there may be some validity because we're more cute as humans to recognize patterns in sound than we are in light, which is kind of, but aurora themselves, coming through space, we're not going to be able to hear anything per se. Once the aurora hits our atmosphere, then what we would be hearing would be electrical interactions that's causing the air to vibrate. And I've had 1 or 2 times with super strong aurora where here, and my dad, who grew up deep in Northern Ontario, would talk about hearing the Northern Lights as a kid, which I always thought was fascinating. It's only something I think once or twice I've ever, you need to be in a really silent spot. Unfortunately, our part of the world is just not quiet enough, but where he grew up, and this is going to sound weird, but just outside of a prison farm in Matheson, Northern Ontario, it's deadly quiet up there. And he said, as kids, they will all talk about hearing the Northern Lights, which I think is really neat. The other thing on the website that's here is some data from satellites that's mapped in various different ways. So again, you've got the density and a number of other measures that are there. And my take on this, I don't know all the science and how to read it by eye, but when you see this graph on the left, having lots of gaps and big jumps going up and down, it's going to be a good time for aurora. Over here, there's a video that you can play that is a projection of what the expected disturbances that are coming off the sun that they're aware of will look like over the next few days. It's a guess. It's not going to be 100% accurate, but if you play this video and freeze it just as you see one of these dense areas hitting the Earth, it'll give you a pretty good idea of timing. And again, the satellites can only measure so much. The sun is a remarkably bright object and they're all pointed at it. So trying to see something that's come off the sun coming directly at us is really challenging. But if you look on social media, Tamitha Skov is a space weather forecaster. I believe she's in the California area. She's fantastic. She does like a little YouTube channel on sort of like the space weather forecast for the next few days. And she'll often refer to this graph and then talk about sort of what's the range of error that it might have. And she's incredibly knowledgeable. And so she can get in all the details about why this one might be accurate or might, next time it might be less accurate. And it's really great. She's one of the people that I kind of keep on my social media feeds. She starts saying something interesting is coming, it's gonna be a good event. So when the aurora hits, one of the other things that happens is that coronal mass ejection hits the Earth. You get all that plasma coming in, but it's not actually the plasma per se that you're seeing in the sky. It's actually the atoms of the air of the Earth's atmosphere that are getting excited by all that energy that's coming in. Light and magnetism are interacting and kind of part of the same thing, I guess is maybe the simple way to put it. So when we see green aurora, which is probably the most prevalent color that we'll see in aurora or photograph in aurora, that's coming from excited oxygen molecules that are somewhere 100 to 300 kilometers above the surface of the Earth. You see pinks and reds, that's being generated by nitrogen. If you see the deep reds, that's oxygen, the 300 to 400 kilometer range. So that's kind of interesting, right? Lower oxygen, which is lower in the atmosphere, tends to be green. Oxygen, which is higher in the atmosphere, tends to be red. And you'll see a lot of aurora pictures that are quite spectacular where the bottom is green and the top is red. It's actually oxygen all the way through. And you can see a bit of that just in this photograph where down along the tree line, it's kind of greens and yellows and gets progressively more red and purple as it goes up. Blue and purple are hydrogen and helium. So again, the colors actually tell us what is being excited in the atmosphere. And as we talked about before, the speed of the hit, the magnetic direction, the density of the plasma are all contributing factors to how intense it's going to be. When we have aurora, there's now a standardized measurement to be able to figure out how intense that aurora is. So we can look and go, oh, that's great. But one of the challenges is what we see here and what somebody sees 500 or 1,000 kilometers away at the same, I always get my longitude and latitude mixed up. At the 42nd parallel, let's put it that way, is going to be different because there's what they call substorms. Different parts of the Earth see things differently. And even though these are massive phenomena and we may all see it, we're seeing it from a different angle. It's like parallax. So this disturbance storm time index, or DST, is a measurement that was developed in the last number of years to give us the relative strength of different events. So almost everyone in RASC has probably heard of something called the Carrington event in 1885. It is in recorded human history the strongest aurora. Things were visible down easily to Cuba and Colombia. Pretty much the entire world could probably have seen the aurora that night. Telegraph operators received electric shocks while attempting to telegraph. Some stations could continue to operate even after unplugging their equipment. That's how much energy was flowing through the atmosphere, electromagnetic energy. Like, just think about that for a moment. Can you imagine unplugging your desk tower PC and having it stay on? That's how much energy was flowing, right? That is an astounding figure. And a number of telegraph lines actually lit on fire. So this was sort of the start of the electronic age, and telegraphs were really the main form of communication. But that was astoundingly powerful. And so the DST measurement is always in the negatives. So this event, they believe, the best estimate is somewhere between minus 800 nanoteslas and minus 1500 nanoteslas. And that's the strongest event that we're aware of. There was an ejection from the sun about a year and a half, 2 years ago, that was believed to be this strong or stronger. It just happened to go away from the Earth. But one of the commentaries was, had that headed for us, that would have been a test of satellite design, because it would have been so strong. We've not had an event that strong in the satellite era. And there's serious questions about whether or not our engineering technology is in fact sufficient to protect us from that level of event. So in the modern era, I mean, there is potential for there to be, I'll call it a communications apocalypse, if we have another Carrington level event. And, you know, the estimate is maybe those only happen every 500 to 1,000 years. It's just humanity has not had electronic technology for that length of time yet. So we haven't really had that upper test. And one of the things we know about humans is we tend to underestimate things that we don't believe will happen very often. And as someone who grew up near Walkerton, Ontario, you know, everyone knows that story. This may be the space version of that, I don't know. 1989 was one of the biggest events of the last century, and that was minus 589 nanoteslas. Some of you may remember that caused a massive outage through Quebec and parts of Ontario. 9 hours of outage. The TSX shut down because 3 key hard drives failed in the RAID array from the electricity fluctuations that were happening. We had substantial worldwide communications outages, and it was probably the most impactful storm in history. And it actually led to the solar helical observatory satellites being sent up by NASA and the ESA, because people realized if you do have a really strong event, and remember, this is probably somewhere around 2/3 to less than half of the Carrington event, and it was able to cause all kinds of chaos. So a very strong event. We haven't had one that strong since. But it kind of gives you a perspective of the things that can happen if you're not prepared. In 2003, we had Halloween storms. A few folks here might remember seeing Aurora then. That was minus 422 nanoteslas. This one was interesting because it was about on par with what we had last May, but it was our very first solar storm during the full-on space age. So back in 1989, there still wasn't a ton of stuff up in space, right? Not to the extent that we have it now. By 2003, there are hundreds and thousands of satellites now that are floating out there that need to be taking into account what if we have events of this level. GPS systems and satellites were impacted, and what was interesting here is this was also the start of the social media age, and this was the first time that you could instantly see pictures from around the world. And of course, 2003 was right when we started having digital cameras where this kind of stuff could be a lot easier. Film cameras would take you weeks. Now we're in the area of instantaneous communications, both because of the space age, but also because of social media and digital cameras. And they talk about 2003 event being as a huge sea change in the general public being aware.
Yeah, I'm sure some people here would know this already. So if you're talking about the power and communications going out, that includes telephones with jacks. I remember 1989. Does it affect telephones that are put into a jack? That's a different system than the electrical.
Well, yes and no. So if you think back to the telegraphs, that was all wired at the time.
Okay.
So the challenge is anything that's electronic, when you have that much electromagnetic energy running through the atmosphere, is potentially going to be impacted. And so engineers since '89 have been building more and more tolerance for that kind of fluctuation. We're also using, telephone technology, I don't think has changed dramatically, other than voice over the internet. But the original, phone jack ports, that's still very much running through copper wires that are the same. So it could be quite impacted.
I remember 1999.
Yeah.
Telephone jacks.
Yeah.
Was fine.
And remember too, like, that is our end user scenario, but a lot of those things are being transferred by those microwave towers, right? So then you've got a whole signal to noise problem that happens when you have wireless, between the headquarters and whatever regional network has the landlines. It's probably being beamed, and if it's being beamed, depending on what frequencies radiation is happening, you've just got a signal to noise problem. So in imaging, your sensor is noisy and there's a lot of random fluctuations. In an Aurora scenario on electrical grid, those fluctuations are going to be much, much higher. And so if you're trying to transmit data, think of what happens to your satellite TV if you've got like a Bell dish or Shaw or something like that, and there's a big windstorm, right? And it's shaking your satellite dish, so you're kind of going in and out of signal, and you'll be like, oh, or you'll get where sentences,
Okay.
right? You get that effect happening where you're losing data along the way. The same sort of thing can happen. My son's working to be an aerospace engineer, and he actually called me yesterday. It's really cool. I designed a satellite in class today, and one of the things that they have to be thinking about is, what happens in an aurora situation. And now we're actually seeing in the news the other day, they were saying the May and October events were so strong, it actually impacted the orbits of a number of satellites and probably caused them to deorbit quite a bit sooner, like months or years earlier than planned. So there's a whole string of impacts that happen, and I'm sure some of them are physical, but I think a lot of it is electronic.
So it affects telecommunications.
Yeah.
They don't even know yet.
I think there's a good idea of what is theoretically possible, but whether or not we can handle those once in 1,000 year events. And what is the repercussions? And so a lot of things changed in the last 20 years to try to deal with this. My concern with the US shutting down their space weather prediction center is the networks may be able to handle it if there's sufficient warning, but what if we don't get sufficient warning, right? So just like the wind turbines in high winds will shut down, face a certain direction to prevent damage, satellites are going to do the same thing, but if nobody knows it's coming, good luck. So to put it in perspective, the storm in May that I think most of us got a chance to enjoy was minus 412 nanotesla, so very, very similar to that 2003 storm. But we didn't have near the impacts that we're talking about from 1989. There was definitely GPS problems. I certainly experienced that. We were down at Wheatley Provincial Park camping, and our friends who were coming down had never been there. Were like, my GPS was going crazy, and I'm like, well, I think I know why that's happening. And then in October, we're about 3/4 of that intensity, but that aurora, interestingly, at times was as spectacular, I think, as the May one was. So the interactions here, we've talked about this a few times. So BZ, which is the magnetic orientation, is negative. We get stronger aurora in the northern hemisphere and a lot more structure. So if you witness the October event, one of the things about it is, other than a few moments, there was a lot of times where it was super strong, but you didn't see those big, beautiful pillars. It was just very diffuse. And that happened because the magnetic alignment was the same as the Earth's. And so the Earth, there wasn't as much structure, there wasn't as much interact going on, but the high solar wind was very strong and the solar density was very strong. And so that did mean we had a strong aurora. It just was very bland compared to the May one, where if you saw the May one just after the sun went down, I've never seen anything like that in my life, and I'll show you a few pictures. By the way, as someone who's very hesitant about using AI in broad application, while I was researching this, I wanted to remember what NT stood for. And of course, Google has its AI to answer all its questions. Anyone notice anything a little weird with that response? So NTs are nanoteslas, not the Newfoundland time zone. But it would be cool to have an aurora where you know what's happening in 30 minutes for sure.
Not for 30 minutes later.
30 minutes later, yeah, you're 30 minutes late, sorry. Rick Mercer comes out on your app like, dude, does a rant for you and talks about the clouds, that'd be great. So here's, this is something I came across. So there's a study that looked at the May aurora, which is on top, versus the October aurora. And you can actually see a number of things. So this is looking at the density. And on the scale underneath the multicolored scale here is the KP index, or something that's very similar to the KP index. And if you take a look at it, you can see that the May event lasted quite a bit longer with a lot of peaks and valleys, whereas the October event peaked right around midnight universal time on the October 11th, and then gradually settled down. But you can see the shape of those graphs is very similar in terms of there's a buildup, you reach a peak and it comes down, and that's because the coronal mass that's been ejected, has that sort of flow to it where you get the stuff that's really fast and got ahead of it, then you get into the dense stuff and then it starts to settle down again. What was really interesting here is this is a number of magnetic field pieces of equipment that were all around the world put together in one graph, and they talked about how the May event rang like a bell. And if you look at all can't say the word today. Perturbations?
Perturbations.
Yes, thank you. You can actually see like how crazy they are compared to the October one. So one of the things that made May really spectacular is I think it was 6 or 7 coronal mass ejections all within a short time. And some of them were more violent than others. And it just happened that the timing of them coming out, they got more and more violent. So the ones behind were moving faster and they caught up and all kind of hit at once and lasted for about 3 days, I think, in total. The October one is interesting because you can actually see some oscillation, happening that's a little bit different. But you don't see the same sort of, as they call it, the ringing of the bell of the Earth's magnetic field. So it just goes to show you that every aurora event is going to be quite different. So let's talk about, we know there might be an aurora event, where are we going to go? This is a very depressing map of the part of the world in which we live. So where I grew up is, for those who can see this in the room, this dot right here, a little bit of yellow light, my hometown of Chesley. So I used to have pretty much what it would be gray if you went back 30 years ago when I grew up. Now that's all kind of blue and green, so Bortle 3-4 now. So you're gonna have to drive a long ways if you want really pristine dark skies. And frankly, Bruce Peninsula is the only reasonable place you're gonna get north to on a day's drive anymore. And up there it's tough because you have a lot of cloud coming off the lake. But there are a few spots around town that I quite enjoy that I wanted to share with you. So just zooming in a little bit closer. The first spot, Sharon Creek Conservation Area. For me, it's great. I live just a little bit to the east of there. So for me, it's about a 10-minute hike over. I'll show you a shot from Sharon Creek in a moment. What I like about Sharon Creek is you have the water, so you get nice reflections if you have aurora. You definitely are still getting light pollution from London. But one of the nice things about there is if you just follow that arrow straight north, you're not getting the lights of Strathroy, the lights of London. So if the aurora is due north, it's about as good as you're going to get without getting into one of those green zones. There's going to be nights where you don't have a lot of time and you don't want to be up in the wee hours and driving tired and exhausted. So it's a really good spot to go to. The road is not very busy, so I've often set up on the road there, just on the shoulder, and you're a little bit elevated, so you get a good view to the north. Many of you, of course, know the Elgin Field Observatory. Been lots of RASC events there. That's nice because you're actually getting up into the Bortle 4 area to the north. So it's pretty good. Challenge, of course, is if, like me, you live in the south end of the city. Getting through the city is, almost an hour sometimes, especially if it's in rush hour when you're trying to get north, depending on the time of year for sundown in 6 or 7. But it's a good spot to go because you've got pretty clear skies to the north. There's a great little spot just outside of Glencoe. If you can get down to it, you're gonna have really strong aurora. It's actually pretty much due north for 200-300 kilometers. There's just not a lot of light pollution. You will see some of the lights from London, but not usually where you're gonna see aurora. You get a few more lights from Strathroy there. But if you have the ability just to pop down Highway 2, it's actually the closest we can get into that sort of Bortle 3-4 range. Fingal is not so great, although I've seen some spectacular aurora there just because the greenhouse at Frome is directly, to the northeast. So I like that area a bit better. One of the spots that I've discovered recently is just a little bit to the south and east of Grand Bend. Because of the lake, the skies are really quite good. There's not a ton of light pollution to the north, and there's some really beautiful cornfields and stuff in the fall that for the October aurora that we managed to catch there. And it was actually one of my favorite places I've ever gone aurora because you get really nice foreground from the corn. I know Craig and a few others have gone to in and around the Grand Bend Forest area. Yeah, there's a few spots there right on the bend of the lake, which is great because then you've got Lake Huron, you've got the water. But there are a lot of cottagers, there's a lot of people, and there are some places now, I think, where they get a little bit nervous if people are showing up to hang around with tripods and cameras at dark, so just be aware of that. One of my all-time favorite places, if you can get up there and if you've got a trailer, the site where Starfest is at River Place Campground. Really nice clear skies to the north. Owen Sound is about, I think, 75 kilometers to the north. There's a little bit of light pollution there, but it's quite low on the horizon. You can camp. You're up high, which is always good for astronomy in general. And the campground's got a big wide open plain. There's There's some problems with one of the lights they put in a few years ago, kind of flooding the fields. They turn off for Starfest, so in non-Starfest times it's a little annoying, but I got some great aurora shots. I'll show you a few from up there. And the fact that you're up at that point, more like the 43rd to 44th parallel, it is amazing how much better the aurora is on a modest aurora. Just getting up a little bit, as Bill can tell you, if you can get up to Killarney at his place, it's spectacular, which we're all very jealous about, but that isn't a bad, like that's a 2 to 3 hour drive depending where you are in London. And if you've got a tent, it's an easy place to go to, and it's a pretty easygoing park, and they're used to astronomers there, which is nice. You only get the occasion drunken person in a golf cart blinding you with the lights, wondering what you're doing with the camera at midnight. So this is actually at the Starfest site. You know, it's funny, this was not the strongest aurora, but this is one of my favorite aurora shots, and that everything kind of worked out. You can even see Andromeda in there if you look just a little bit above the top of the tree. One of the things to think about if you're doing aurora photography is how are you going to frame the shot? So this is now, you've talked a lot about the science, this is going to be a lot about the artistic side. This had just been built when I did this. It was about a year or two before the pandemic. And I was on the way down. At the time we had a trailer at that trailer park, and I was on the way down to my place, and I turned around and realized the aurora had started up. And also the Milky Way almost looked like smoke coming up out of the recreation center there. And I thought it made a really interesting shot because, like, think of all the astronomical features that are like right in one shot. You've got aurora, you've got the Milky Way, the northern Milky Way, and you've got Andromeda all in one shot. And anyone not being interested in space would still going to go, hey, it's kind of an interesting combination of things that are there. So foreground shots for aurora can be really tough because most buildings, which you'll see a lot of people like the old dilapidated barns and stuff, some great shots have been taken. Joe Neal used to go find a bunch of those places and hang out waiting for aurora. Did some great shots, probably saw them on the forums. But a lot of those places are getting more and more lights on, right? So suddenly you're shooting into a light and it's really tough. What was nice here is this was the week of Starfest, so they had red masking on all the windows there, and just the red glow matched the red in the aurora, so I quite liked it. But think about Milky Way alignment too when you set up, because it's pretty, you know, we just kind of point the camera at Polaris and don't think. But as I'll show you in a few of these shots, if we really think about the space that we're in, we can get much more interesting shots. For a foreground object, this is taken up by Strathroy. This was a couple days before the big October aurora. There was a really nice night about 2 nights before. And one of the things that I'd always wanted to do is get one of the windmills that were there. And sorry, it looks like there's a giant red heart on the screen here on the laptop. It's much nicer looking when it's come out there, but I really want to get the blur of the blades in the shot. And that took a lot of fiddling because I actually needed a really fast exposure. And of course, we're used to doing long exposures, but if you did a long exposure, the blades were moving so fast in the wind, it just blurred them out and it just looked like a post. So again, that took a little bit of thinking. And what was interesting here is I'm not shooting north, I'm actually shooting a lot more to the east than I am to the north. And that was, I would say, you know, a strong moderate level storm. It wasn't a spectacular storm of a couple of nights later. And that let me really do some framing and take a longer lens, a longer focal length. I'll show you 3 lenses in a minute that I use. And this is sort of the one in the middle. So not the super wide shot, but a little more narrowed in. And I turned it portrait instead of landscape to get the tower, but also get the pillars coming up. And I thought that one worked out really well. This is from up at Starfest. So this is a diffuse aurora. So this is what happens when you get aurora, but maybe the magnetic field's not lined up, or maybe the magnetic field is lined up, but then it was just slow, not very dense plasma moving through. So as you can see there's basically almost no light pollution in the north from Starfest. There's a little bit of glow off to the right from Durham, but it's not too bad. Here, one of the things is I could have been a lot closer to the tree line to try to get a shot. But there's these beautiful rolling hills that are there. And so I actually set up low on the hill, which is the opposite of what we normally want in astrophotography, right? You want to be on the top of the hill because you get scene effects. But here I was able to go down to get the rolling of the hills. And because of that, you see that the light pollution there, that's coming from their recreation center. Big giant LED light that all the astronomers hate and just floods the field. But it actually gave something interesting to the foreground. It was like a light painting of the foreground, but it let me get the aurora that was there. And of course, you've got a little bit of the Milky Way as well. Stillwater is amazing. It's just really hard. I mean, go to Bill's Place in Killarney, that bay is ideal. But around here, we don't have a lot of still water without lights reflecting off of them. So there's a few spots around town, but like even if you did like Westminster Ponds, you're kind of in the middle of London, that's really tough. Sharon Creek, I really like because you've got the road that runs there. You don't have a lot of, the only thing here is the hydro towers off to the left. I actually entered this into a photo competition with a photo club, and they told me it had the hand of man in it and it was eliminated as a landscape. And I said, what do you mean? And they said, well, you can have the road, but you can't have the hydro towers. And that was the last time I ever entered because I thought that was the most ridiculous thing. And I'm like, and the rules actually said, like, if there's a thematic reason to have something man-made, like, you know, barn owl in a barn, it would have been acceptable. I'm like, it's a giant electrical storm. Like, and it's electrical wires, like, would that not meet the criteria? They're like, nope. And I was like, okay, that's the last time I'm entering that one for an astrophoto. But I did love, like, you can see the reflection of the aurora in the dammed area there. And there were some nice pillars coming in. So that's a great spot to go just to get some interesting shots if you can get too far out of the city. Now, what's interesting is we have a strong aurora like May or October. The aurora itself, and I'm sorry, I have no idea where the purple's all getting washed out like that there. The aurora itself actually had a pyramid-like pattern to it that was quite interesting. And so if you're in the moment and you have a camera that you can move quickly, you can actually get some really interesting leading lines simply by moving yourself around and changing different angles. And I scrambled here to do that. That's from Wheatley Provincial Park. Some of the glow that you see is from the greenhouses in the area, unfortunately. This was amazing. This is looking south over Lake Erie at Wheatley at the height of the May aurora. And I call this one Mount Everest. It's again, it's so washed out in there. My apologies. If you see the original, I think I've got it up in the forum somewhere. It was just crazy. It really looked like Mount Fuji or Mount Everest. And I was able to use the trees as a bit of framing on it as well, so you can kind of see the lines all lead your eye in the same direction. So again, if you can in the moment, if the aurora is strong enough, like think about where you might reposition yourself. And because of that, don't assume that north is going to be your best shot. You can get a lot more interesting structures in profile to the northeast or the northwest. Here's a great example. This is from the October one. This road runs east-west, so that tells you what direction I'm pointing. And because the aurora was so strong, I couldn't get the whole aurora in a shot right to the north. But as soon as you turn a little bit to the east and use some of the landscape, I actually think it made a much more interesting picture. And same thing, this is the same night, this time turning to the northwest. You really get the sense of how massive the aurora was that night. And again, like I've got a bunch of shots where I was straight north because I had a camera doing that, and they're kind of boring. But it was like seeing the exciting stuff off to the side and the structure that was there that really made that spectacular.
And that was bright enough too, that wasn't something you only saw on camera. That was.
Oh yeah, we were seeing the
there.
colors. Yeah.
Even though it was, the sun was still just setting, you could see something happening in the sky.
Yeah, actually, when Bridget and I were driving up there, you know that sort of sunset blue that happens to the north? It was blue-green, like it was like an aqua green. And I remember driving, Bridget's like, I think it might be happening now. And I'm like, no, there's no way. And then I'm looking at the sky and of course, I almost go off the road because I'm like, oh my God, you're right. You could actually see the aurora. The green of the aurora was bleeding through just as the sun was setting into the blue of the sky. And your brain was trying to process it because it wasn't a normal, it's not a normal thing you would see. This is actually my favorite shot of the night. And it's interesting because the aurora was fading a bit. It's a bit of a noisier shot. But I absolutely love this because the yellow color that happened. So when you talk about processing, this is kind of a dull shot if you see this in Photoshop. And this is a good lesson of when we're processing aurora, some auroras are going to be so intense it's going to be easy, but there's going to be some that are fainter that have really cool things going on. So this shot, the reason it's a little bit noisier if you saw it on this screen is because the aurora had started to dim at that point. And yet, just as these giant pillars were fading, it was one of the most interesting structures that I saw. It really was like a rainbow. And it was the angle of it because the storm was moving off to the west at this point. And so I was able to get the shot, and I loved it because the cornfield in the foreground is so crisp. And then you can see that yellow into the reds and then the greens off to the side. And if you looked at this, it was kind of a dull shot, but as I sat there with the contrast slider, pulled that up, did some curves that I would normally do for like processing a galaxy or nebula, all of a sudden it just popped right out. And I didn't have to play with the vibrance or the saturation. So sometimes if you've got a raw file, and that's the best way to shoot anything, if you can, have the raw file, whether you're using Photoshop or GIMP or your camera's own software, there'll be ways to tweak those settings. If you see a structure that's really interesting, don't be afraid to really tweak, because sometimes you can pull something out of it. And this is actually, even though it's technically not as good as some of my other Aurora shots, that pattern, the light, the angle, the line, the way that you can actually, the corn here, the brightest spot you can see, but then it disappears in the background, just everything about it, I just personally really love that shot.
Right, this is astro modified camera.
Yep. You know, I don't have any of my terrestrial cameras modified. I've got dedicated astro cams for Galaxy and Nebula, and I do so much terrestrial photography in the daytime, that can be a bit of a pain. If you're doing casual stuff, I think it's fine, but I do a lot of wildlife and birds and things, and it gets really hard because you lose the natural state of things, and then you need filters and again, you know, works if you have a dedicated astrocam, you can use it occasionally, but for the amount of photography that I do, and I've never had a problem with Aurora. Like hydrogen alpha doesn't really, you might get a little more intense reds, but I don't think anyone's ever tested Aurora where it made a massive difference. And certainly for the good Aurora. And you'll see a video in a second, I'll show you just how bright the Aurora can actually be. This is panorama. You might recognize the towers here. That was a tower from the other shot, same night. So getting a panorama is one of the coolest things because there is, on a good night, there is no wide enough lens where you can get the whole sky, right? To get what feels like to be there. And the panorama, to me, this was really captured it. So this is 4 shots on a tripod at f2, 4 seconds, ISO 6400, and I used a 28mm focal length. This is actually one of my favorite lenses to shoot Aurora on, even though it's not a wide lens at all. But what I love about it is you can turn it portrait, you can keep it landscape, but what it does is it lets you do a panorama, because once you get wider than about 24mm on a full frame, which would be the equivalent of about 18mm if you've got an APS-C camera, you're getting a lot of distortion no matter what lens you have. And it's enough distortion that you're not going to be able to get your software to do a panorama, and it will drive you bonkers. Because the wider the lens, the more distortion has to be built in there. And so that's why you'll see architecture photographers will use these tilt shift cameras, tilt shift lenses that are specifically designed so that they can place things exactly as they're supposed to be. Those tend to be fairly slow. They're like at 4.5, f5. They're not great for Aurora. So the best thing you can do is actually go to a slightly longer focal length because there'll be less distortion, and then take a series of shots and put them together. The thing is, most Aurora are changing so quickly that if you go longer than about 4 seconds on a shot, I mean, this is 16 seconds from the left side to the right, plus probably another 4 or 5 seconds to just quickly reposition. You need a good tripod, you need it well leveled so you can just let the knob, you know, go, take it, move. It's really difficult to do panoramas and have them line up in a very intense Aurora like this was. So the longer focal length makes it so much easier. And I had a 14mm running on my other camera, and there wasn't a chance I could do a panoramic photo because there was just too much distortion. You get all these weird artifacts that come out. It just, yeah, you get a fisheye effect, and you don't even get a good fisheye effect because a fisheye is designed to give you that whole wide area, and it just, the 14mm is not. So basically, you want to figure out whatever your fastest f-stop is on your camera, and then move fast, really fast. The longer you take, the more likely you're gonna mess things up.
So to take this photo, you took it in 4 quarters
Correct,
and then merged it later in software?
in software.
Okay.
Yeah, so you have to overlap. I like to do about 1/4 to 1/3 of overlap. The more overlap, the easier it is for the software algorithm to line things up.
Does this camera do the trick where you tell it you're gonna take a panorama and then you just literally move the camera?
I think the camera is a capability, but I always do it in software. Because I'm shooting in RAW and I want to be able to tweak all the colors. And the ones who do that, you're gonna get a JPEG and you're gonna get whatever the camera thinks it's supposed to be. You could do this on an iPhone. I mean, some of these nights in Maine, the very last shot, Caitlin took a Virgin Eye next to the cornfields with either Bridget's iPhone or hers. I can't remember whose it was. And it's spectacular, like handheld on an iPhone in the middle of the night with Aurora backlighting us. I never thought that shot would happen. So the handheld camera phones now are amazing. They are using AI out the wazoo to do that. So you still kind of have to watch. You get some weird, funny things that happen. But that night, you probably could have done panorama mode on your phone. It's pretty incredible. My Samsung, I've got a Samsung S10. Not so much, but some of the new iPhones have been pretty good. The other piece here that's super important, if your camera, and it should somewhere have the ability to show you the histogram, you want to make sure that for Aurora you're exposing properly. And this is just great advice for any kind of image. But in Aurora, I see a lot of really dim shots where people have had to really stretch to get the Aurora to pop out. You get a lot of noise and color noise and blotchiness, and the warmer it is outside, the worse that is. What you want to do is get your histogram, kind of like this one, where the peak of it, which is going to be the dark part of the sky, is off from the left side, and you want to expose to the right. So you're trying to get as close to the right as you can without blowing it out. That's a pretty good safety margin there because Aurora can fluctuate pretty rapidly in brightness. So if you can get here to about 90%, you're in pretty good shape. Here's a great example. So this is a shot from Starfest. I took a few test shots that night. So this is 10 seconds at ISO 3200. And if you look up here at the histogram, can you see it's all really bunched to the left? And so, you could stretch that and get close to that final shot that I had, but it was really crappy. Like it was really noisy. There was a lot of color blotching and it just you couldn't get a lot of contrast. So on the next shot, because I was watching the histogram, I went up and I went to 30 seconds at ISO 3200. And what was really interesting on this is right away you can tell it's a better shot. At this point I wasn't in the spot in the landscape that was quite right, but at least I knew what my exposure settings needed to be. And the thing is, if you know the ISO that you're using, if I go, wait, 30 seconds is too long, I'll get star trailing. Well, I can go up to ISO 6400. So there's basically quick math that you can do in your head about your exposure and your f-stops to get you where you need to be. And this was a manual lens, so I'm not sure what f-stop I was using. I think I was trying to get the foreground and the background in, so it could have been at f8, which is why it was a long exposure. But being able to see that histogram in the back of the camera is a godsend. I'm doing a workshop in June that I'm super excited about with one of Canada's finest wildlife photographers. And I attended a session he did for one of the camera places in Toronto a few years ago. And one thing that's stuck in my head, he said most amateurs always are too conservative about how much you can overexpose a shot. So if you overexpose a shot, you're swamping noise and you can always make it darker. He said if you're starting with too dark of a shot and you're trying to make it brighter, you almost always are going to end up with a crappy image. And he said, I have so many people come to my workshops and they're like, my camera is too noisy. He's like, that's not the problem. Problem is you don't have the right histogram. And so you don't have the data to be able to manipulate. If you're like this, you've chopped off most of what your camera is able to do. And no matter what you do, it's going to be noisy. So you could have a $10,000 camera with virtually no noise on the sensor. It's still going to be a crappy shot. A $10,000 camera, it's probably a better shot than your $100 camera that you bought used from 10 years ago. But it's no matter what, it's going to be a crappy shot. So he said, you're always better to overexpose and then pull back than you are to underexpose and try to pull up later. And that's the classic photography triangle of your ISO, your shutter speed, and your aperture all work together.
What would you be focusing on a shot like that?
We'll talk about that in a second. bear with me. I actually talked specifically about that. But I'm always trying to focus on the stars. But what I will do if I want to get the foreground, I will change my f-stop, which means I need a longer exposure. So it's always a trade-off. But it means you have to think carefully about if you were going to have a really cool object, like, I don't know, say a plant or a flower, and you want to get an aurora shot, and you're really big close with a wide lens, that's really hard because your depth of field as you go, if you're shooting f2.8, which is pretty wide open and, a good range for aurora, your depth of field is maybe only a few microns if you've got something really close, or something that's far away. you know, you've got maybe several feet that's gonna be in focus and maybe it's close enough that you're gonna be able to get the trade-off. So again, positioning becomes really important.
Is there a, like, the magic triangle, is it slanted in any particular way?
No, and that's the cool thing about it. So your decisions about a shot
Okay,
depend on how fast you need your shutter to be.
right,
Now, this is not for space because they only go to
Yeah.
1 second and we're
Yeah.
often, you know, starting at 1 second. 1 second's like super fast for space stuff. But the idea holds true. So, you know, how fast do you want your shutter open? With Aurora, I try not to go past 10, 12 seconds. And that's usually for a faint Aurora without a ton of structure that's moving quickly. I prefer to be in the 3 to 4 second range. I find that's a pretty good trade-off. The coolest Aurora I ever saw was actually fluctuating every half second. That was amazing. It was bouncing up and down, and there's no, like, without video, I don't know how that could have been captured. Aperture controls your depth of field, so back to this gentleman's question. Aperture, the smaller the light that's coming in, the more is gonna be in focus. The wider the aperture, you can take a much faster shot, but you're also prone to more distortions in stars and a few other things, and depending on the nature of your lens, it can be very hard to control. And the ISO, that's very much how much dynamic range you're getting from your sensor. Modern sensors, that's really solved so many problems. You know, my DSLR from 10 years ago, I'd be reluctant to shoot over ISO 1600 because it just degraded really quickly. My cameras now, I have no problem shooting at night at ISO 12,800. I could probably go to 25.6 in some circumstances and still get a usable shot, which is crazy. So sensors have become a lot cleaner, a lot less noise, so it gives us a lot more options. This is, yeah,
is that an improvement in technology or an improvement in manufacturing?
both.
Okay.
So,
Like, when I say techno, like, it's not AI,
no, so
Fixed.
AI denoising has helped a lot of things because you can
Yeah.
have a noisier shot and clean it up.
yeah,
And that's like the one place I think where AI is really great in machine learning because noise is a very predictable pattern.
yeah.
And AI doesn't have to make crap up to fill in the noise.
Right.
It's pretty predictable.
Yeah.
Other AI things, the danger of AI, and I love this one. I did a talk at Starfest a couple of years ago, and I love, there was an AI researcher, he said the problem with AI is when it makes stuff up, it's completely believable. He said before, if a computer made something up, you'd be like, yeah, no, right? And if you think of that like 7-fingered hand, you know, or the lady who's holding a tray, but it's actually her foot holding it, but it's attached to her hand. Like you look at that and like, okay, well, when you first glance, you don't see it. And one of the blur exterminator, which is one of the great AI tools that's been developed for astrophotography, it fixes stars that are a little wonky, they've got coma in corners. The first time I ran it, it turned a star with coma into 3 separate stars. It's completely believable, but it's wrong. So that part of technology, it's helping us with certain things, but it's actually the manufacturing of chips. So when I started astrophotography around 2010, a really good sensor had maybe about 10 to 15 electrons of noise. I forget there's an E minus that they use, I forget what it all stands for. But in comparison today, most of them around 1 to 2. So, and it's a logarithmic scale, so the amount of noise is not 1/10, it's actually well beyond that, it's maybe 100th. So the sensors now on any camera that's been built in the last 5 years are phenomenal, and that's right down to entry level stuff. The stuff that's entry level now, the quality of it blows away professional stuff from 5-6 years ago. It's nuts. It's a really exciting time to be in photography. So this is the May Aurora, this is Wheatley, this is south, looking over Lake Erie, and this is the brightest Aurora I've ever shot. This is f2.8, 4 seconds, ISO 2000, this was KP9, this is looking south over Lake Erie. And what I've done here is the whole series of shots is processed exactly the same. So same contrast, same dynamic range, same, like there's no, I haven't done anything to smooth this out. This just tells you how wild the differences are from moment to moment. And remember, this is only 4-second shots. So what's that, 60 divided by 4, you know, 15 shots, you know, within a minute here. So just watch this. Whoa. Wow. You probably saw that, that's the ISS going past. You remember seeing the mountain shot I showed you? Could you see it in the middle there when it ran through? Okay, now here was my lesson. So first of all, I had clouds coming in, and I knew they were coming in, so I was trying to get different shots. What I didn't realize is I thought the Aurora was just kind of done. It's like, wow, that was spectacular. It went on for another 18 hours. And Andrea Jerome, I don't know if anyone knows her, a friend of mine in Ottawa, probably one of the finest astrophotographers in the country. It drives me nuts because she just started when COVID hit in 2020 and she's so good, it's disgusting. She literally won every Starfest category one year. They told her she couldn't enter again, she can only be a judge from now on. She was like, that was her 3rd year doing imaging. I was like, that's not fair. She's super talented, but she was taking shots all night long in her backyard because the clouds didn't hit there until the next morning. In Wheatley, they came in, and so, I moved. What I didn't realize is the Aurora had actually gotten dimmer because it shifted south. It was out over Ohio, and so, the really bright stuff was when it was directly overhead. Well, it was going south, and I thought, okay, maybe it's fading. No, it really wasn't. It was still there. I wish I kept this going. But one of the things, if you just watch this again here. Maybe one. So you see how bright that got. Caitlin's, there's some stuff going on. She's got some family down tonight, so.
Oh, okay.
Yeah,
'Cause
she may have, yeah, she probably chose to go off. I know she mentioned to me she may have to exit. But if you saw like the brightness change, like that's really hard because you don't want to have to touch the camera in the middle to change the settings, but it's such an extreme difference. You have to really think about what camera settings you're using because I got great shots through this. But the quality of one versus the other could really change. And if you had overexposed, if you'd done 10 seconds when that really bright part, you can see how washed out it was there. I try and find a setting where like that wasn't totally washed out, but the other stuff was still visible. And it was ridiculously hard. I thought, this is the best, this is the best Aurora I've ever seen. And if I'd have been wrong in my settings, I'd have been toast. I'd have been so upset because it would have washed out the whole sensor. It was so bright. So when in doubt, shoot at your fastest f-stop, even if stars are wonky. So as astrophotographers, we're often focused on getting nice stars to the corner. Some of the best Aurora shots I've ever seen, they're trying to shoot the Aurora. Nobody's going to notice the tiny little corner star, and actually you clean up a lot of that with some AI tools now, even if it turns into the 3 stars. Don't worry about that. Shoot at your fastest f-stop. Get the Aurora. That's the spectacular thing. Just, hopefully you've got a lens where the stars aren't too ugly in the corners. Crank your ISO to 6400 or even higher if you've got a camera that can support it. Older DSLRs, probably 3200 is the limit. I can get into a whole technical discussion that nobody's going to care about why that makes a big difference. But basically, as your ISO goes up, the read noise of the sensor goes down. So you don't, it used to be people are like, oh, it gets noisy. It really doesn't anymore. It's actually the opposite. There'll be a sweet spot, but usually I find the sweet spot's around 6400 to 12.8 on modern cameras. Then decide on your shutter speed based on the intensity of the Aurora. Watch your in-camera histogram. And then on stronger Aurora, just remember a longer shutter speed actually becomes your enemy because you miss a lot of the details and blur everything, and the structure can really come in. When it's strong, it's like every second it changes. So don't be afraid to go shorter, but crank your ISO. It's not a sin to have high ISO in Aurora. The higher ISO, maybe the better your shot's going to turn out, ironically, which is different than we might have told you 10 years ago with old cameras. So
But you had that caveat, know your camera, that's.
know your camera, like that's always, know
Yeah,
your gear.
that's huge.
These are the lenses that I use for Aurora. This is an awesome little lens. It's a cheapie, it's a 14 mil Rokinon. They're also branded Samyang. They used to have a couple of other names. I think it's just Rokinon and Samyang now. They're like 400 new, 200 used. I've seen them go for like 120 or 150 bucks on Astro Buy Sell. They're available for almost every camera brand. I don't know anyone they don't make them for. They're all manual. But you have to watch out. There's a wide range of quality control. I unfortunately dropped mine and chipped the back element. It was a really good one. I went down, there was one for sale when I was in Toronto at Downtown Camera, and I threw it on, and like that was so soft and so terrible. Like you couldn't get anything in focus. So if you're buying used, try them first. If you're buying through Amazon, like people sometimes go through 2 or 3 copies before there's one that's reasonably decent, but they're great little lenses if you can find them. It's just they're cheap because the quality control is a little bit wonky.
Yeah.
There's a version 2 and an autofocus version that apparently are more consistent now. I haven't tried them, but you're going up in cost on those.
Yeah, I got a couple older ones. One's slightly newer. Quality's perfect. The it says Infinity is exactly that. The older one I got from my brother. never used. The infinity mark is, it never was so way off, like, it's terrible.
And that's a good point. Infinity doesn't mean infinity when you're focusing on Aurora. There are a lot of lenses that say this is the infinity. Don't just put it there. You actually have to look.
And also too, if it's ED elements in it, it goes past infinity. So if you just,
Yeah.
in the old days, you would just put your manual focus lens to infinity, it was an infinity. Now you can go past infinity, so you actually have to bring up the star and maybe magnify it and focus on the star.
Yeah, Buzz Lightyear to infinity and beyond. So this is another favorite lens. This one's, it's still very fun. The Canon 60-35 L/f4. You can probably find these used now for probably $650, $800. They're a bit of an older generation, but this is actually one of the finest landscape lens that Canon ever made. There's a lot of professional landscape photographers. I think when they came out, they were selling for about $1,100 brand new. I think now they're probably $1,500 new, it's gone up. They are fantastic lenses. They're small, they're lightweight. They don't collect a lot of dew because of the coatings on it. It is okay for stars. Zoom lenses are almost always worse than a prime lens for stars. But the zoom really lets you frame easily, right? 'Cause sometimes you can't walk into that farmer's field, but you want to kind of zoom in on something. It really lets you do that. There's very little distortion. It's just the difference between 14 millimeters and 16 millimeters will shock you. When you see it, you're like, it can't be that big of a difference. That's only 2 millimeters in focal length. But when you're that ultra wide, like it is amazing. It's probably 30% wider to go to 14 millimeters. And it's one full stop slower, right? F4. But most modern cameras, you can just crank up the ISO. So I find that's a good sort of secondary lens for me in my second camera if I want to move around, frame in, capture something. It's great. This is my favorite landscape multi-use lens of all time. It's stupid expensive. The only reason I have it is that we use it for videography for my company when we're doing web broadcasts, so I'll steal it if there's Aurora. This is insane on color rendition. So this is a $4,000 lens. I wouldn't suggest you run out and grab it. It's like a holy hand grenade. It's massive. It's a half stop faster than my Rokinon Prime, right? F2 is pretty darn fast. And you can shoot it at F2, no problem. It has some of the best lens coating that has ever been put on a camera lens.
Is that such a monogram Ryan Fraser?
No, no, that's the new Canon mount. The stars are not as nice, but gosh, mom, I love this lens. Like, if I had to marry one of my lenses, it's this one. There's nothing quite like it. Wedding photographers love this one because it's great in low light. If you got a friend or you can borrow one like I do from work, it is actually my favorite Aurora shots are all taken on this just because the colors really pop. And that's the thing, right? To get colors at night to pop, you need all those coatings, you need little reflection, and just like a really good telescope to give you more contrast, you're going to pay for good quality optics. I have a Canon R6 Mark I that I own personally, an R6 Mark II for work. I'll often grab them and pull them out. But like any mirrorless camera that's been made in the last 5 years of any manufacturer is phenomenal. Full frame is ideal for Aurora because you want to capture everything. On the Canon side, the R7 is great. I didn't put the R8. My friend Chris Klinowski, some of you might remember, was a RASC London member for a while before he moved for a job in Hamilton about 10 years ago. He's got the R8 and he's just blown away by it. And it's now, I think, their cheapest full frame camera, and it's amazing. The R50, my son has the R50, and it might be the best Canon value camera right now. It's an APS-C sensor. It does everything remarkably well, and it's a really nice, it's just a really nice piece of kit. So there's some really good stuff out there. The Canon R100 would probably be fine for Aurora, but apparently it's terrible at everything else. So just if you're Canon, but like Nikon, Sony, they're all great these days. One of my big learnings a year and a half ago, when you choose a tripod, you could spend a ton of money on a tripod, and for the most part, you're not going to care because it's nighttime photography and you're not dealing with animals or birds where you're going to leave it and set it. But the one thing I encourage you to get is a tripod with that kind of leg extender where it's a latch versus the twisties. So the problem with the twisties, you want to twist them, it's dark and the leg falls out. There's a little plastic piece that provides the tension that now is on the ground somewhere that you may or may not have just stepped on. It's in dewy grass that you can't see, and now you have to get a light to try and find it because it's black and grass looks pretty black at night. And then you make everyone really mad. So don't be Ryan. And just get yourself a tripod with those legs. These have become really popular, probably because they're cheaper to make and they're pretty good these days, but honestly, I will not do night photography unless I have. I just,
Doesn't the same thing happen with the latch version?
No.
You
No.
flip it open and the leg drops
No.
out,
well, the leg drops out, but it doesn't drop off.
stops.
And that's the difference, because they can build, I guess, a stop in it that works, whereas here, there's no stops. When you loosen it up, it's all gone.
And if they get, like I have one of my, like the better ones, the carbon fiber one. Something got, it sticks now, and I've taken it apart, I've cleaned, I put it back, and no,
You
it's
get grit.
still sticks.
Yeah. They're great because they're lighter weight, right? Because those latches actually weigh a fair amount, the good ones, but, yeah, definitely hard running. The ball head that you use for the camera is actually really important as well. Craig introduced me to these guys who are really, I love these. So there's the silver thing that you see on the knob actually lets you adjust like a minimum tension amount. So one of the problems is we got these big wide lenses and your camera can be really off balance. And so if you undo it, all of a sudden it falls right down. Again, you're in the dark with expensive camera gear and you might have like your dew heater and stuff attached and you can lose all of it. So I really like these because I can keep them at a certain tension because I know I'm always going to be trying to be level. I might go up a little, down a little, side a little, but I'm never going to move that much. So I can really dial in the tension to be in the right spot. Dew control. This is like the greatest thing that's happened to nighttime astronomy on a camera. You go into Amazon, wherever you want to go, you can find these dew heaters that are USB operated now on 5 volt. Get yourself a battery bank. You go all night long on them. They've got a little thing to increase. You don't need a big $500 dew system from Kendrick on your camera. You can just use these little 5 volt things and they work remarkably well. You just have to watch every once in a while if you've got a poor quality USB power bank. They don't always like them, so you just want a decent quality power bank. And I just have like a little bag sometimes. I'll just put the power bank in and hang it like an extra weight from the hook on the bottom of the tripod, and then just run the dew heater up, and it works great. That 14mm Rokinon dews up in a heartbeat. You have to really crank the heat up on that, and even then you'll still lose at some point on a dewy night. But they're great and they're stupid cheap. I mean, $50 will get you both the power bank and the dew strap. For time lapses, those work best with one very good wide angle lens. So the Rokinon's my go-to for that. Does require a great deal of patience on a time lapse and good focusing early on. So like Dale mentioned, you got to zoom in, you want to zoom in the stars. And one of the problems with focusing for Aurora, a bat knob mask on a wide lens doesn't really do much. So if you're not familiar with bat knob mask, is a little thing you can 3D print or buy. It goes on, and when your star is perfectly in focus, it creates a perfect X with a line through the middle. If your focus is off, the line shifts. It's a great visual tool. It's just stupid hard to do that on a wide angle lens, and almost always Aurora are going to be on wide lenses. If you have the moon in the sky, that is a great way to get yourself at infinity focus, even if it's a crescent of the moon. But of course, focus will change through the night a bit, which makes it a little bit challenging. But once you start your camera, you don't want to touch it or it's going to wreck your time lapse because you'll see that. And you might have noticed in the one right as the ISS went through, I kind of checked something on the camera and just knocked it a little. Most cameras now have built-in intervalometers right in, but you can buy again off wherever you want, a little electronic intervalometer. They don't cost very much. The cheapy ones, basically you set your camera on your manual settings for 4 seconds ISO or whatever, and then you just lock that shutter into place goes. You can use your phone now on a bunch of them, so that's way simpler than it used to be. So you point it, you hope, and you have patience. The reason you want to have patience, this was one of the most spectacular auroras. So this was not last year, this was 2 years ago. This was, the next one's from 2 years ago. So this was from this year. This was 2 days before the big one in October. And we went out that night, had a nice spot north of Strathroy. And, there's Aurora, it's diffuse. And I just let the camera run. And I was tempted at some point going, it's getting a little chilly, it's getting a little late, I gotta work in the morning. Should I go? Watching all the planes, I'm like, well, that's cool. Maybe I can do some star trails with this. And then all of a sudden it got a little more intense.
And then you called in sick?
Well, I own the company, so the boss can be a real jerk, but there we go. Look at that.
Wow.
right? So patience is really important because I've seen so many people go out. And there was back around 2015, there was a St. Patty's Day aurora where a bunch of folks went up to Elginfield, and one of my dear friends had wanted to come out, and so she drove all the way with her husband. They got tired and they left, and then it exploded. And I'm like, she said, "Oh, we're back in London." She's like, "Yeah, it just wasn't what I was expecting. It wasn't that exciting." I'm like, "It's because you left."
That's never happened to me.
No, that's never happened to Craig at all. We'll talk about that in a minute.
Right.
So, yeah.
Was that a time lapse exposure or with an intervalometer, or was that?
Intervalometer. All mine are with an intervalometer running.
So there was probably 2 seconds, 4 seconds. Or.
Yeah, I'd have to go back and see what I had on that one.
Approximately, and then you just stack them
Yeah.
for purpose.
Well, they're not even stacked. So,
I mean, not stacked.
yeah, they're just put in a time lapse
Time
in a-
lapse.
in a sequence, yeah.
What do you use for setting up the time of the sequence?
And on my cameras, it's built right in,
Oh.
so I just get my settings, I do a few test shots, and then I just tell.
Oh, so it's a
put it to
JPEG you put
infinity.
in camera? Those?
No,
Okay.
it's built right into most of the Canon cameras now as an intervalometer.
Okay.
So you just do it in the settings, I tell it to take one, what, I've got all my settings in there, and I just tell it to take an infinite number of shots, and I just let it run. And when I'm done, I turn off the camera. At some point, you can run out of battery too, so if you get one of those like battery extenders for your camera, that's super helpful. So this one was interesting, so this one, Craig and I like ran north, we looked at all the satellite apps, we got to a spot finally with clear skies. And, we were really happy here because it was nice and diffuse, and then all of a sudden it just blew up. And this one was so cool, my wife on her iPhone from the south end of London overlooking all the city lights. She could see it naked eye, get it with her iPhone. It wasn't as strong as May, but this pulsing thing was going on. So not only aurora like got the pillars and stuff, but I remember I was sitting there going, "Oh my goodness," because there was like, and it was about a half-second frequency, and there's no way you could catch that on a camera without video. And it's something I wish I could describe, but not only were the pillars going up and changing, but it was fluctuating up and down, and that's when I started understanding my dad talking about Northern Ontario and hearing the lights and watching them dance, what he really meant. Common problems that I see, bad focus. And we've all had that because you think your camera's focused, but you didn't zoom in enough, you didn't check, or you nudged it, or the temperature really changed. So use live view, zoom in to estimate peak focus. Moon is great. Autofocus or manual focus aids in camera if they work. Sometimes if you have a really bright star, like Sirius, your autofocus might actually work on that, which is fantastic. Usually, as I mentioned, the background mask is fairly useless though. Rapid temperature drops, infinity is not infinity, we talked about that. Unless you're shooting at 5.6 or higher, it's really hard to get close foreground in focus. F8 is what they call the don't care landscape setting, but F8 is way too slow for 99.9% of aurora we're gonna see. If we have an aurora that you can shoot well at F8, the world is probably gonna end anyway, so enjoy it if you can and put the camera away. Bumping the camera, this is a huge one if you're doing a time lapse. So very dim glow in the dark plastic can be your friend to remind you where tripod legs are. I just found some glow in the dark filament up at Canon Computers the other day, and I was like, oh, I should have bought some and made little pieces to wrap around my tripod legs. So the problem is you put blinky lights or whatever, you're gonna see those in the landscape in front of you and probably tick off the other people with cameras around you. So, I mean, those are great for your telescope that's pointing up into space that's super zoomed in, but when you're at 14 millimeters, I mean, honestly, if you sneeze, you would probably see the droplets in the frame. So a dim glow in the dark, just to let you be able to mindful of where your feet are, because it's so easy to forget, especially in spectacular aurora, because you're like, look at this, and then you realize you've knocked your several $1,000s of camera gear over. If you have a dual battery camera grip, use it. And we talked about getting a good quality tripod. You want a tripod that's heavy enough that people walking around, because there's always going to be people walking around, is not going to jiggle it. Underexposure creating noise, we talked a bit about that. Biggest contributor to noise is not your high ISO, it's the fact that you're underexposing. If you're underexposing, that the histogram is going to tell you every time. So expose to the right on the histogram, and your goal is to maximize the signal to noise ratio of your shot. That is your goal for every type of astrophotography shot. Maximize your signal to noise ratio. I can't think of any method of astrophotography where that is not important as one of your key things. Because no amount of denoise software can make your signal stronger. All it can do is smooth out the noise so your signal stands out more. You want as much signal as you can, and so getting that histogram to about 90% puts you in the safe zone where you're gonna be fine. Poor and boring framing, like aurora themselves are spectacular. But really think like aim left, aim right, look at your landscape. Roads, buildings, trees, they're all your friends. So look and think, and sometimes a tiny little shift, like there was one day I'm like, it's just not working for me. And then I realized on the really wide 14mm, the road was kind of being distorted. And so I literally shifted the camera like maybe 3 or 4 degrees. And all of a sudden the road follows a straight line. And you go, oh, okay, there's the shot that you're looking for. So really think about your environment.
Do you ever bring lighting to light foreground? There's no lighting that's.
Depends how many friends I have. If it's just me, yes, it's very easy to do that. If you've got other people and they're doing time lapses, you're gonna wreck their time lapse. Yeah, you can light paint. I think that makes, the better way for me is if you've got something closer to a full moon, the moon's gonna do that for you and it's gonna be very diffuse and everywhere. The challenge is, most of the time I find for aurora, you're getting such a broad swath of landscape that whatever you're highlighting with the light painting, it's gonna look weird because you're there. Now, there's some shots, there's that like cliche one with the dude with the headlamp. You know, that kind of stuff where that makes a little more sense if you're trying to really get something in. That works if you have a really deep background. It's very far off and something in the foreground, you can highlight that. But you have to really experiment and be careful on that, but it can be done. Just if you got a lot of other people there.
One solo shot that I did, so no one around me, not bothering anyone. I used a headlamp and actually painted a tree. And you got the aurora behind it, so.
Yeah, you just have to really think it through and experiment, and that's the fun part about this, right? The not so fun part is you do something and you don't realize later on and mess something up, and I've had that where I've done something like that, and like, oh, I was doing that time lapse, and I have to throw out, 5 minutes of frames, and I can't do a star trail anymore because I mocked it up, so. And you can fix some of that in post, but it's really hard. The other one is where you have the headlamp, and then without thinking about it, you look into the camera that's taking a picture on a time lapse. I've done that one a few times, and like, why is my stupid, oh, Ryan, what did I do? And if you have a zoom lens, try zooming in and out a bit, just to see if it can make a really huge difference on getting you from a dull picture to an interesting one. And sometimes like just a couple millimeters makes a difference. 2 cameras are better than 1. I like to have the ultra wide lens for my time lapse and then use one of my other less wide lenses to just kind of look at interesting structures that are happening. Second camera, usually I use the 16 to 35, try to get some of the side details. This was a good example. This was at Sharon Creek. This is right around the same time of the one where I showed earlier reflecting the water. Turned out we had a Steve going on. Nobody knew what Steve was at that point. I think the study came out like a couple months later. And they're like, oh, that's what that was. But this was actually like pointed directly south, and the Steve was way south. A few of my all-time favorite shots. So this is from May. This is one of the ones that was totally blown out. I just love that it looks like a bow tie. It's going right overhead, and just every shot in there, if you played with it, and you saw how wide that dynamic range was. So like, I'm smoothing these out for individual shots, but it was like the hardest time lapse ever because it was such a wide dynamic range, and there was just no way to do that. You can probably do it in video with brightening stuff dynamically, but it's beyond my skill set. But I mean, this is one of my all-time favorite shots. And again, unfortunately, this TV's washed it out, but it looks like an angel in the sky. And it's just, the random structures that are there. And if I had gone longer than, a couple seconds for that shot, it would have been totally washed out and smeared. I love these ones because, again, these are my longer focal lengths off to the side. And this brings to me the just the immensity of the aurora, right? How small you feel next to it. And so I love going to portrait for that. And of course, my one final secret, always take former RASC National President Craig Levine with you, because the number of times we've been out, Craig's like, I'm tired, nothing's happening, I'm going. And one of my favorite shots ever, he turned around and left, and I'm calling him going, you need to turn around and look. He's like, I'm already on the 402, I can't exit for 10 minutes. I'm like, it's spectacular. And we sat there and there was nothing. So again, patience is your friend. And that big one that happened where we chased the clouds, same thing, it was night, it was an okay aurora. And Craig's like, I'm packing it in, and he literally took his camera off and it exploded. And I'm like, okay, this time nature was your friend. You weren't on the highway yet. And I'm like, okay, he's putting it all back together. I'm like, this is amazing. And so that was the shot, actually. This is where we had that. And this is also the same day where I learned about those tripod legs falling out. But there was nothing. There was absolutely nothing, and then it hit the second Craig left.
Take them along, and if nothing's happening, ask them to leave.
Exactly, and it has worked every single time. So Craig's gonna have many friends now.
Yeah, it's true. Every time I leave the party, I always gets better to see it.
Yeah, so this was the night, like, we were happy with this, right? And it turned into that. So again, patience is your friend. And in retrospect, you can see how blurry this is compared to some of my other shots from May. I was too long. These, I think, were like 8 or 10 second exposures. And so it's a great shot, but it's just, you don't see the same fine detail because the structure was moving so fast. But it was a time lapse, and once it started, you don't want to touch it and change it. So, and then my final one, and I know Caitlin had some family over tonight, but this was the shot she took of Bridge and I in October on an iPhone, which blows my mind. That is where technology has gone. So, you know, take your friends with you. Because you never know, you might, we would never thought of that. I was so focused on my cameras. And Caitlin's like, hey, why don't I do this? And we did that, and it's a lovely shot of the two of us.
What was that exactly? I'm trying to recall.
That was just to the south, southeast of Grand Bend. In that, on my map, that was the.
So they were zigzag. I lost where that we were.
Yeah, that was there's nothing but Bortle 3-4 north of us. From there, and the cornfields just actually worked really, really well. We were looking for good landscape. Any questions? Now that I've soapboxed to you for way too long. Well, thanks very much.